On July 30th, 2020, a routine training exercise off California killed 8 Marines and a sailor when their amphibious vehicle flooded and sank to 385 feet. That vehicle was over 35 years old. Fleet readiness was below 55%. So when you hear the Marines' $4 million replacement is impossible to sink, the real question isn't whether that's true. It's what went so wrong that they had to build it. At 5:45 p.m. Pacific time, the first sign of trouble came through a radio call. Water was flooding into the forward compartment of an assault amphibious vehicle carrying 16 people off San Clemente Island. In minutes, the vehicle's bow began to rise. Crew members tried to activate the bilge pumps, but the main pump failed, and the backup system had already been flagged as unreliable in the maintenance log. The engine seized and cut all propulsion. Inside, the pressure mounted, literally and psychologically, as water rushed in faster than anyone could bail. The command to abandon vehicle was given at 6:04 p.m., but for many the escape hatches jammed under the force of the incoming sea. Only a handful made it out before the hull slipped beneath the surface at 6:06 p.m. The AAV disappeared to a depth of 385 feet, trapping 9 service members inside. Navy divers arrived 14 minutes later, locating the vehicle by the oil slick leaking from a breached transmission line. Their helmet cameras captured a warped hull, a transmission case torn open, and the unmistakable evidence of a catastrophic mechanical failure. The official investigation later confirmed that a loose drain line had allowed oil to escape, seizing the transmission, which in turn disabled both propulsion and the main hydraulic pump. Maintenance records showed overdue inspections and missing repairs, while training logs revealed that only 2 of the 13 Marines aboard were fully qualified in underwater egress. Sergeant Mendoza, one of the survivors, later said that the hull tilted, water rushed in, and the training they had on underwater egress felt like a nightmare. The exit hatches were hard to open under pressure. The rescue effort recovered the remains of 8 Marines and 1 sailor. The physical evidence, oil-stained water, a breached hull, and a jammed propeller, told a story of mechanical failure compounded by maintenance lapses and gaps in training. On that day, every weakness in the legacy system converged in a matter of minutes, with fatal consequences. The assault amphibious vehicle entered Marine Corps service in 1972, designed for a Cold War battlefield that no longer exists. By the time of the 2020 sinking, the average hull had been in service for more than 35 years. Corrosion crept along weld seams, electrical wiring became brittle, and spare parts grew harder to find. Maintenance logs documented a growing backlog. By 2018, fewer than 55% of those assault amphibious vehicles were considered ready for deployment at any given time. Crews routinely faced vehicles with overdue inspections and critical repairs deferred by necessity, not choice. Their planned service life was 30 years. Decades of budget constraints and shifting priorities forced the Marine Corps to stretch that timeline well beyond its limits. The result was a fleet that demanded constant attention just to remain operational. Depot-level overhauls lagged behind schedule, and units often relied on waivers to keep aging vehicles in the water. These waivers became a fixture of daily operations, masking the true scale of readiness decline. The 2020 tragedy was not an isolated case, but the most visible in a long line of accidents and near misses. Reports from the Naval Safety Center cataloged more than 30 hull losses since 2000, with over 100 injuries linked to mechanical breakdowns, hydraulic failures, and water ingress. The Commandant's order to suspend all assault amphibious vehicle waterborne operations after July 31st 2020 was not just a reaction to a single disaster. It was an admission that the risks of continued use had become unacceptable. The call for a new vehicle was no longer a matter of modernization, but of necessity. On November 13, 2020, the Marine Corps declared the Amphibious Combat Vehicle ready for initial operational use. This announcement came just months after the assault Amphibious Vehicle disaster, and it meant the first ACVs would enter service with combat units on an accelerated schedule. The sense of urgency was unmistakable. Less than 4 weeks later, on December 8th, the program received full-rate production approval, authorizing the manufacture of hundreds of vehicles. Program Executive Office officials and Marine Corps Systems Command made clear that this was not a routine milestone. It was a deliberate, high-level commitment to overhaul the Corps' amphibious lift, with institutional backing from the Secretary of the Navy and the Commandant. The decision locked in the ACV as the backbone of future ship-to-shore operations, ending years of incremental upgrades and stopgap measures. Delivery of the first operational batch followed soon after, with initial units sent to the 1st Marine Expeditionary Force for field evaluation. The rapid transition from limited fielding to mass production reflected both the pressure of recent losses and the need to restore confidence in amphibious capabilities. With these approvals, the Marine Corps staked its future on a new platform, one designed from the outset to address the hard lessons of the past. The Amphibious Combat Vehicle's survivability suite is the product of hard lessons, not wishful thinking. John P. Graham, a senior systems engineer at BAE Systems, describes the ACV as a platform built to withstand the very failure modes that doomed its predecessor. At the heart of the design is a double-hull structure, an inner monocoque shell made from high-strength steel, surrounded by an outer hull that forms a sealed buffer zone. This double-layered approach boosts crush resistance by 30% compared to the old AAV, offering far greater protection against both impact and flooding. Inside, buoyancy is managed by self-sealing chambers and flood control valves. If a breach occurs, the system automatically isolates the affected compartment, preventing water from spreading unchecked. Controlled tests have shown that even with a 30% hull breach, the vehicle remains afloat, a result that far surpasses the legacy platform's performance. The ACV's dual propulsion system adds another layer of insurance, twin water jets for sea travel, and independent land drive, each with its own power source. If one system fails, the other keeps the vehicle moving, reducing the risk of being stranded and swamped. A digital damage control management system, DCMS, constantly monitors for leaks, pressure drops, or abnormal vibrations. The DCMS triggers alarms and activates countermeasures within seconds of detecting a problem, giving crews precious time to respond. These features are not theoretical. Each was validated in a battery of controlled flood and blast tests that exceeded military standards. The result is not a vehicle that defies the laws of physics, but one that turns the odds previously stacked against Marines at sea back in their favor. A 12 nautical mile water range is more than a number on a spec sheet. It is the distance that lets Marines launch from beyond the reach of most coastal defenses and still hit the beach as a single cohesive force. In practical terms, this buffer keeps the parent ship far enough from shore to reduce exposure to anti-ship missiles, while still allowing for a rapid armored landing. The ACV's ability to operate in sea state 4, with waves topping 1 meter, means it can handle the kinds of rough water that would have sidelined earlier vehicles. Inside the hull, space is allocated for a full rifle squad, 13 Marines with combat gear, plus a 3-person crew. This is not just about comfort, it is about operational tempo. Instead of splitting squads across multiple vehicles or running extra sorties, the ACV delivers the entire team in one lift. That single platform approach reduces time spent in the water, cuts down on exposure to hazards, and preserves unit cohesion at the most vulnerable moment of an amphibious assault. Dr. Susan M. Larkin, a defense risk analyst, quantifies the impact. The ability to move a full squad over a 12 nautical mile gap in a single vehicle lowers the probability of catastrophic loss by an order of magnitude compared to the legacy fleet. In her assessment, the ACV's operational envelope is not about making the vehicle unsinkable, but about making every sortie more survivable and tactically coherent. These design choices reflect a doctrine that values calculated risk over wishful thinking, translating engineering into real-world advantage for Marines between ship and shore. A price tag of $4 million per vehicle draws attention, but that headline figure only scratches the surface of what it takes to field a survivable amphibious fleet. The full program cost for the Amphibious Combat Vehicle sits at $3.2 billion, covering research, development, procurement, and 30 years of maintenance for 632 vehicles. According to the Department of Defense's Selected Acquisition Report, about 63% of that total goes directly to purchasing the vehicles themselves. The rest funds the unseen essentials: spare parts, training simulators, logistics support, and the infrastructure needed to keep the fleet ready through decades of deployments. Congressional budget hearings have probed these numbers, weighing the urgency of replacing a risk-laden fleet against the realities of defense spending. Lawmakers have pressed Marine Corps leadership to justify not just the sticker price, but the long-term investment in reliability and readiness. Each ACV represents a calculated trade-off: more upfront investment in survivability and support, and less spent on crisis repairs and emergency waivers down the line. The cost breakdown reveals a program built for the long haul, where survivability is measured not by miracle claims, but by the resources committed to making risk manageable year after year. No vehicle rewrites the laws of physics. The Amphibious Combat Vehicle is not invincible, but it is a calculated response to known risks, not a miracle fix. Today, survivability means disciplined design and realistic expectations. The risk equation has changed, but the sea remains as unforgiving as ever. Share your thoughts below.